Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli. A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear brothers and sisters in Islam, Assalamu alaikum wa rahmatullahi wa barakatuh. My today's video is a continuation of my previous lecture 1. So we will start from where we left off. In this video, we will utilize the third option for Al-Kashi's theorem. So let's go draw the triangle. Point A, point B, the gravitating mass. At O, R prime, V, T. Angle phi, angle theta. And this time, the angle that I'm going to use is third angle, gamma. Okay, using Al-Kashi's theorem on triangle OAB for the third angle gamma, we obtain R square is equal to R prime square plus V square T square minus 2 R prime V T cos gamma. Differentiating with respect to T, we obtain the derivative of R is 0 because R is constant. Dr prime over dt plus 2v square t minus 2v t by dt R prime cos gamma t cos gamma dr prime over dt plus R prime d by dt t cos gamma dr prime over dt t cos gamma dr prime over dt plus R prime cos gamma plus dr prime minus sin gamma d gamma over dt. 0 is equal to R prime dr prime over dt plus v square t minus v t cos gamma dr prime over dt minus R prime v cos gamma plus R prime v t sin gamma minus d theta over dt. Gamma is equal to phi minus theta plus. Let's take the limits now. When t tends to 0, R prime tends to R and gamma tends to pi minus 0 is equal to R dr over dt plus v square 0 minus v0 cos gamma dr over dt minus R v cos pi minus phi plus R v0 sin gamma minus d theta over dt. 0 is equal to dr over dt minus rv cos pi minus phi. Dr over dt is equal to rv cos okay, so dr over dt is equal to v sin beta. Let me write this equation. Call this equation 1. Okay, so we will rewrite this equation 1 here. So rewriting equation 1 as below. R prime v t sin gamma. Now we will differentiate the above equation with respect to minus v cos gamma dt plus t d by dt cos gamma dr prime over dt. Minus v d by dt r prime t sin gamma d theta over dt dt. So 0 is equal to dr prime over dt whole square plus r prime t square r prime dt square v square minus v cos gamma dr prime over dt. Here I missed the term. R d theta over dt plus t d by dt r prime sine gamma d theta over dt. So we'll start from here. V cos gamma dr prime over dt plus r prime v sine gamma d gamma over dt minus r prime v sine gamma d theta over dt. We don't need this term because when we take the limits, when we make t tends to 0, then this term will become 0 when multiplied with 0. So we don't need this term. So we'll skip this term. Okay, so when t tends to 0, r prime tends to r and gamma tends to pi minus phi. So we get 0 is equal to dr over dt whole square plus r d square r over dt square plus v square minus v cos pi minus 5 dr over dt minus v cos 180 minus 5 phi of 5 dr over dt plus rv sine 180 minus 5 minus d theta over dt minus rv sine 180 minus 5 d theta over dt. 0 is equal to v square sine square beta. We'll put the value of dr over dt, which is v sine beta, and we'll put the value of d square r over dt square, which is v cos beta over r. R cancels with r, so we are left with v square cos square beta plus v square minus 2v minus cos phi dr over dt minus 2rv sine phi d theta over dt. Okay, we're pretty close. 0 is equal to 2v square. This plus this is 2v square. V square sine square beta. Dr over dt is v sine beta. And minus 2 r v cos theta d theta over dt. Okay, so we have 0 is equal to 2v square cos square beta. V square minus v square sine square beta is v square cos square beta minus 2rv cos beta d theta over dt, which gives us v cos beta is equal to r d theta over dt. Okay, so with the third combination of Al-Kashi's theorem, we have got the same answers. So dr over dt is equal to v sine beta and v cos beta is equal to r d theta over dt. In my previous lecture, previous video, I called Tahir angle as field angle, meaning that irrespective of the mechanical system or the driving force behind the particle has to follow the same angle and the same equations, meaning that inertia does not need to be there. There can be another mechanical system that drives the particle, and the particle moves under different conditions of forces.